This is Ham College, episode 76 for April 15th, 2021. This episode of Ham College is brought to you by ICOM. The great outdoors is calling. Get outside and under the stars with one of ICOM's ultimate SDR transceivers. Good evening and welcome to another episode of Ham College. I'm Professor Thomas.
And I'm generally cheap.
It's good to be back with you tonight. And Tommy was not able to be with us this week. So we have the general stand in here. He did such a great job the last time around. And these questions are really tough tonight. So.
Wait, what?
Oh, I didn't tell you? Oh, I'm sorry.
You forgot to mention that, okay. Professor.
Well, we're studying for the extra class amateur radio exam here, and they're getting tougher. The last few weeks, it's like the toughness meter just keeps on going up. So that's all right, though. We're going to get through this one way or another. There could be some buzzer action for you tonight. We'll just have to see on that one. Anytime we're doing a show live, we've got a chat room going on at the same time. And where is that, General?
The chat room is over on the internet. Oh, you mean like how to get? Okay, yeah, it's at AmateurLogic.TV/chat, and you should be able to join in the fun. And it's at least half the fun, if not more.
What did we talk about last time? You probably don't know what we talked about last time because I didn't. I
might have skipped class too. I might have been out.
Oh, you may have. I don't remember if you were here or not last time around.
I have an excuse.
Well, see if this sounds familiar to you. Transequatorial propagation, long path, gray line. Ordinary and extraordinary waves, chordal hop, or sporadic E mechanisms, or, as Dean likes to call it, cordial hop.
Cordial hop?
Yeah.
Is that like a dance?
That's what I said.
Well, just if this week has anything to do with that, I'm in trouble.
I think I said it's a sock hop, but I don't know. This week, or this month, I guess, since we only do one of these a month. Do you know what we're talking about?
I'm guessing it's going to be similar or somewhere in the same neighborhood.
Like maybe radio horizon, ground wave, propagation prediction techniques and modeling, effects of space weather parameters on propagation.
Oh.
Yeah.
I might know some of that.
Yep. You're going to want to dust off your big piece of smoked glass for this one because some of these you probably don't want to look at directly. There's some tough ones. Well, I guess we should just jump on in and let the chips fall where they may. And I see you did bring the pencil. I suggested you brought the pencil.
Yep.
And some scrap paper.
We got the number 2 pencil, as you said there, and some good old scrap paper for writing those complex math problems I know we're going to have.
Did you bring your slide rule?
I don't have a slide rule, but I do possibly have found a workaround or a loophole in the testing rules because I don't think anybody said you couldn't bring your smartphone abacus app.
Well, I don't think they'll let you bring a smartphone, but if you've got an abacus,
Okay, I
You,
might have to. I might have to get a real abacus. Well, we'll see.
yeah. If you're like me, that abacus wouldn't do you much good. So,
Right. Well, I did figure out how to make a 73 out of it there. It's kind of really hard to see, especially
yeah,
when the camera doesn't focus on it. But that is 73 in abacus language, just so you know.
yeah. I never would have guessed that. Just, I'm going to have to practice up on my abacus lessons.
And just in case, for last minute, if we have to phone a friend, George, we can.
Oh, you brought the razor. Oh, okay.
Just
Yeah,
in case.
yeah. We could need some high power help on this one.
What does the radio communication term ray tracing describe? Is it A, the process in which an electronic display presents a pattern?
B, modeling a radio wave's path through the ionosphere.
C, determining the radiation pattern for an array of antennas?
Or D, evaluating high voltage sources for X-ray. What does the radio communication term ray tracing describe? Well, first off, I'm going to say I don't think it's D, evaluating high voltage sources for X-rays. We don't really do X-rays here. At least I haven't explored that portion of the hobby myself. But that doesn't sound like it to me. Determining the radiation pattern from an array of antennas. No, that's not ray tracing.
It sounds like an array.
Yeah, it does. I see where they're trying to go there. A, the process in which an electronic display presents a pattern. Now, I mean, I think there is ray tracing patterns, but I think what they're looking at here is B, modeling a radio wave's path through the ionosphere. I'm going to go with that. What do you think, General?
I think that's a good bet. And even though I know ray tracing was wasn't there some graphics and things in the computer lands too, with ray tracing and things, but
Well, yeah. Now, I think that's why they were trying to throw you off with that.
Yep.
Yeah, one of those answers there. Well, let's see. Oh, the chat room is mixed on this one. I told you this is a tough one.
It's all over the place.
And this is probably the easiest one that we're going to ask tonight.
Oh no. Well, we can't depend on the chat from then.
Let's see. B, modeling a radio wave's path through the ionosphere.
You got it, Professor.
I got it. You know, sometimes luck will prevail. Sometimes.
That makes sense.
Yeah.
You model it, right?
Yep.
I guess you can draw it.
Yep. I really don't know how they came up with that term for it, but it's the only thing that looked close to me. So, all right, I've got one for you.
All right.
You got your seatbelt on?
I do.
Okay.
I'm going to put my super secret audio pencil.
What is indicated by a rising A or K index? A, increasing disruption of the magnetic field or geomagnetic field.
B, decreasing disruption of the geomagnetic field.
C, higher levels of UV radiation.
Or D, an increase in the critical frequency. Let's see. I'll start from the bottom here and go up. Increase in the critical frequency. I'm pretty sure that's not the A or the K index. I seem to remember something on the pi clock that Tommy did a while back about this, and I have been studying for the extra. So C, it's not. I don't think it's D. C is higher levels of solar UV. I don't believe this A or K is the UV. So that leaves A and B in reference to the geomagnetic field, and it's either increasing or decreasing. And because of the rising term, I'm going to go ahead with increasing, A, and that's my final answer.
Let's see.
I'm going with logic.
Well, I'm looking over with you. Yeah, I'm thinking that is probably it, but let's go to the experts in the chat room.
Yeah.
Most of them are saying A.
Majority.
Majority.
And my brother from another mother up north.
Oh, if Mike said it, then.
Plus, it's on the internet, so it's got to be true.
A 50% chance. Well, actually 25% chance because there's 4 of them. But let's see. I want to agree with you.
All right.
Increasing disruption of the geomagnetic field.
Yeah, Professor, there's always terms on the last 2 tests I've taken, right? I am a general. There's always terms that match there. Sometimes they're logical. In this case, it is logical as long as you know what those indexes were for before. And I did. I remembered it being the geomagnetic field and the rising. So, I guess you have to key on some of those terms there. So
you're saying it helps to study?
It does. And to understand a little bit about what they're talking about, those A and K indexes.
True. All right, let's go on to the next one here.
All right, which of the following signal paths is most likely to experience high levels of absorption when the A index or K index is elevated? A, transequatorial.
B, polar.
C, sporadic E.
Or D, NVIS, which that's near vertical incident skywave. Is that what that stands for, I believe?
Straight up from us.
So which one is most likely to experience high levels of absorption when the A or K index is elevated? Well, I don't think it's really going to affect NVIS. Transequatorial. Well, I don't think that's the answer. B, polar. It looks to me like sporadic E because that one is kind of volatile anyway. And I don't know. I don't have a good reason for it. I'm just going to say I think it's sporadic E that is going to be affected. So I'm going to say C. The way you're stroking your whiskers there, I might not be right. But
I don't know if I should say anything at this point. I'm not. What's the rules there?
Well, I don't know that we have rules for that, but I don't think you can tell someone else taking the exam the answer.
True.
Well, let's see. Oh, I could be wrong on this one. Most of the chat room is not even answering it.
Right, and some are saying there's some might and other answers, and it's pretty up. I think I have an answer, but I'll wait.
Well, nobody gave the answer I did, so.
Oh.
Yeah, I might should have picked another one. I don't know. Let's see. Before I go, what do you think it is?
I think. Remember how the last question has the A and K. When you know what those indexes are, geomagnetic. Mm-hmm. Where do we usually get the most interaction? Think about this. Where do we usually get the most interaction when those solar winds hit the Earth?
Yeah, I missed it completely, didn't I?
Okay. Think about that for a minute.
Yep. Yep. Yeah. Listen, is that a buzzer? It is a buzzer. Oh,
Yeah.
well.
That's what I was thinking. Just because of the Earth's, you usually get those auroras and things, and we're shooting over the poles,
Yep.
and everything you shoot at the poles is going to be absorbed, basically.
You're right. You're right.
Only because I've been studying this recently, because I'm, going to take the exam.
Yep. Well, there you go. Chalk up a tough one for the general there.
Yeah. That's all right. I'm sure there's plenty more like that.
Let's see if this one will work. What does the value of B sub Z represent? A, geomagnetic field stability.
B, critical frequency for vertical transmissions.
D, direction and strength of the interplanetary magnetic field.
Or D, duration of long delayed echoes. Yikes. Well, this is the case for me where I can tell you, if I only knew what B sub Z represented. Because
Well,
I don't think I do.
yeah, if you did, I think you could nail this one without a doubt.
Oh man. I might have to go with the blind, point the pencil at it for this one. Let me see. What does the value of B sub Z represent? Duration, long duration. That just doesn't sound right. See, direction of strength of interplanetary magnetic field. Well, interplanetary, huh? Wow. Between planets. I don't think well, B, critical frequency for vertical transmissions. That's something that just sounds wrong about that.
You
Vertical transmissions.
You may want to check on that communicator there and see.
Let's see.
As you can see, we have another problem.
Oh, no. Oh, well. Captain Kirk can't help us. Geomagnetic field stability. Well, you know what? I'm going, let's see. Okay, it pointed at A when I did that, so I'm guessing. I'm just guessing totally because I don't know what B sub Z means, to be honest.
No.
We might have to look that one up. Google it. So what do you think, Professor?
Well, I'm going to have to say I know I cheated on this one. I know what the answer is because I was looking for some interesting materials. I went looking for the answer, and while I didn't quite come up with it, I came up with something pretty neat to look at. Anyway, let's see.
Uh-oh. Oh, we're in a roll.
There's that darn buzzer again.
Oh, well. Yeah, if I only knew what B sub Z meant.
Well, let's take a look at this and see if it helps any. It's a simulation of the Earth's magnetic field interaction with solar interplanetary magnetic field, IMF. The animation illustrates the dynamical changes of the global magnetic field in the course of a disturbance. A temporary compression of the magnetosphere by enhanced flow of the solar wind is followed by a tailwind stretching of the field lines. Eventually, the increase in the tail magnetic field results in a sudden collapse of the nightside field, a substorm, and a gradual recovery of the magnetosphere to its pre-storm configuration. So there you go. It's clear as mud, huh?
What?
Yeah.
So for me, this question is going to be one of those ones when I'm actually taking the test and it comes up, I'll remember getting this wrong and then remember the right answer.
Okay. Oh, all right. When are you taking the test, by the way?
Probably at Huntsville.
Okay.
If not at Huntsville, then at the W5 SLA Hamfest down here.
Well, you got a little while to study yet.
Yep.
So, there's that pesky B sub Z again.
Here we go again. Yep. All right. That's right. It's your turn. So let me read it. What orientation of B sub z increases the likelihood that incoming particles from the sun will cause disturbed conditions? A, southward.
B, northward.
C, eastward.
D, westward. What orientation of B sub z increases the likelihood that incoming particles from the sun will cause disturbed conditions? That's crazy, man. Why would they even ask such a thing?
Yeah, is there I guess there might be north, south, east, and west in space.
It's a good question, and what if you got it wrong, or you don't realize that the planet's upside down at the moment?
Is there an upside down in space?
Yeah, it could happen. Maybe.
I mean, I know we're already disturbed
True.
condition-wise, so can't get much worse for us.
Feeling a little more disturbed right now after seeing the question here. What orientation of B sub z increases the likelihood? Can I borrow your pencil?
Well,
If it was up to me, every one of these would be wrong.
Well, just for the heck of it, we could get. I would pick. In this case, it's best to answer the questions just in case you get it right? So I would always pick, like, where am I from?
That's kind of what I was thinking.
In relation to VE3MIC, where are we from?
Well, we're from the south.
Okay.
We are southward.
So sometimes logic doesn't have everything to do with it.
I believe that is the answer, but I cannot tell you why. I don't have a good reason for that being the answer. Man, they're not even guessing at all anymore in there now. They're tough.
I like some of the answers, though, and descriptions.
Yeah.
I'm not sure I'm going to use that to study, but I like them. Oh.
And we are.
Luck prevails.
That time.
Yeah, that time.
Wow. All right, I'm going to throw you an easy one.
All right. Please tell me it doesn't have B sub V. Okay, good.
By how much does a VHF-UHF radio horizon distance exceed the geometric horizon? A, by approximately 15% of the distance.
B, by approximately twice the distance.
C, by approximately 50% of the distance.
Or D, by approximately 4 times the distance. All right. Once again here, I'll use my bottom up. 4 times, no way. That's getting into like tropospheric ducting land. And I know this has everything to do with the curvature and how much it'll go past that because of something. So C, by approximately 50%, I still think that's too long. Half, nope. B, by approximately twice, that's too long. That'll be 100%, right? And 15 has got to be it, because I know I can hit some VHF, UHF repeaters that are over the horizon or the curvature. What is that, 30 miles or something? Is it 30 or 40? I forget exactly what it is.
Well, the height matters too, but...
Yeah. Yeah, the range, right, that's true. But I'm going to say it's not, depending on all of that, relative-wise, it's not going to go much past 15%. So you might have threw me an easy one here.
Yeah, I think I did. I'm going to agree with you. It is A. It is A for sure. And they're putting answers in the chat room again.
Yep.
Not a lot of them, but everybody got it right who ventured a guess there. Or maybe it wasn't a guess at all. Maybe it was just knowledge. I'm going to agree with you. It's A.
All right. Woohoo!
Yeah.
It is
And
A.
that one to me was easy. That's the easiest one we're going to have tonight because, you know, on VHF and UHF is just slightly over the horizon. And twice or 50% or 4 times, you know, they're not even close.
Yeah.
15% is just over, so.
Which of the following descriptors indicates the greatest solar flare intensity? Is it A, Class A,
B, Class B,
C, Class M,
or D, Class X? Which of the following descriptors indicates the greatest solar flare intensity? I'm just gonna say it's D, Class X, and my reasoning is because when I hear talk about X-class flares, you know, that's kind of when things are going crazy. Those are the ones that I believe make the news more often, or the ham radio news.
Yeah, you hear it. In other words, you've heard it before.
Yeah.
Yeah.
And the rest of them, I've probably heard of a Class M. I may have heard of a Class A and B and don't remember it, but a Class X, I've heard that a lot. So, not very good reasoning. And you and I actually talked about this one prior to the show tonight. So,
Yeah.
what do you think?
So my logic on this one would probably be the fact that X is up there. You know, I don't know if there's a Y and a Z, but X is up there, and they're asking for the greatest intensity. So the logic says D.
Yeah, and you know, that's the one I'm thinking. And everybody, well, not everybody, most of the folks said that in the chat room. This generally cheap guy said BMX. And Arnie said ABMX. But
that's all. It's a sentence.
Yeah, and Mike said Earth is a Class M planet. But
oh, wait a minute.
Yeah, it's not Earth that's throwing out these solar flares, I don't think.
Condition red.
Uh-oh.
Class X.
There you go. You got it. See, logic prevails. And you've heard it before, too. That's important when you're taking these tests.
Well, sometimes. What does the space weather term G5 mean? A, an extreme geomagnetic storm.
B, very low solar activity.
C, moderate solar winds.
Or D, waning sunspot numbers. Okay, so G5. That was the Pontiac just before the G6, right?
Yeah, wasn't that what Tech TV became?
G6?
Oh,
G5.
I don't know. Once G something.
D, let's see, D, waning sunspot numbers. That means it's going down. I don't think G is related to sunspot, but let's see. C, moderate solar wind. Okay. Or B, very low solar winds. Again, I'm not sure the G is related to those. So I actually don't know the answer to this question, but I'm going to use some of my logic here and say that G is probably referring to some type of geomagnetic activity, which would leave me with A, an extreme geomagnetic storm, possibly less than a Pontiac G6 would cause.
I'm going to agree with you, and those in the chat room agree as well.
A G4. Okay, so that's what I'm going with.
And you got it.
All right, logic prevails again.
Okay.
You know, I know there's key things in here you just got to pay attention to, and I've seen it over and over with even in the general and the tech question pools.
So you're saying it's the one with geomagnetic in it because it's a G?
There's a G in front of the 5.
You know, I like the way you think that
Okay.
time. Yeah.
All right.
That was good. That worked out.
All right.
The great outdoors is calling. Get outside and under the stars with one of ICOM's ultimate SDR transceivers. Stay connected while off the grid. The IC705 is a perfect transceiver for hams who want to enjoy both the great indoors and outdoors. It's the perfect QRP companion. This transceiver has features and functions at the tips of your fingers in a portable package covering HF, 6 meters, 2 meters, 70 centimeters, and the weight is just under 2 pounds. 4.3-inch color touchscreen with live band scope and waterfall. 5 watts with BP272 battery, or 10 watts with 13.8 volts DC input. Create your own band opening with the IC9700. This transceiver brings direct sampling to the VHF-UHF weak signal world. This all-mode transceiver is loaded with innovative features that are sure to keep you busy. 4.3-inch color touchscreen with real-time high-speed spectrum scope and waterfall display. Smooth satellite operation with 99 satellite channels. And it supports dual-watch operation and full duplex operation in satellite mode. Visually sees the VHF-UHF world with ICOM's IC9700. Heard it, worked it, logged it. ICOM's IC7300 is a high-performance, innovative HF transceiver with a compact design that will far exceed your expectations. This innovative HF transceiver digitizes RF before various receiver stages to reduce the generated inherent noise in different IF stages. ICOM's IC7300 is a radio that changed the way entry-level HF is designed. Visit ICOMAmerica.com/amateur for more information on all the great ICOM radios.
Coming soon to an internet near you, it's AmateurLogic.TV with your host, the amazing Tommy, master of space and time. Beam me up, Tommy. Inquisitive George, getting the answers to the tough questions.
Where would you put a server in the woods?
You wouldn't necessarily just want to tie one to a tree.
So you put it at the bottom of a lightning rod?
Yes.
And Professor Jim with the hard cold facts.
If you want to climb to the top, you're going to have to go about another 120 feet.
AmateurLogic.TV. We're not fooling anyone.
And I think that's the first sign of Amateur Logic that appeared back in 2005.
Yep. Nice. I do remember Tommy being the master of space and time in several episodes.
He had that little device with him that was just like magic, man. You know? Well, what do you say? I just happen to have an ICOM cap here. And an ICOM Ham Crew t-shirt.
Ooh. Oh, what does Tommy say? It'd be the best looking ham, the best dressed ham?
Yep, at the Ham Fest, whether you're coming or going.
Nice. It's in 3D.
It's reversible. You can't put it on backwards. There is a tag inside, though, just in case, you know. If you would like to win that, how would you go about doing that, Emil? You got any clue?
I'm thinking, George, you might be able to send an email to hamcollege@AmateurLogic.TV to win that.
You know, I think you could, and I believe there'll be a drawing every month They'll go through there and just pick a random entry. As a matter of fact, we have a random entry right here tonight. Let's see. It is Anthony Hazard. He sent us an email, and, well, a good answer here, Anthony. He said, best show in TV.
I like the way he thinks. This is my drawing, George. Does that work?
No.
Oh, man.
You didn't email it in.
Oh.
To hamcollege at AmateurLogic.TV.
Rules.
So, if you'd like to win next month's prize, ICOM hat and t-shirt, doesn't cost you anything. All you got to have to be qualified is a name and an email address. Don't have to be a ham. We're not sure if Anthony is or not. I think he may be, but don't have his call sign on here, so I don't really know. Anyway, congrats, Anthony. You're going to look good, both coming to and leaving the Ham Fest, as Tommy would say.
Congrats.
So, General, how do you feel about tonight's question pool so far?
I'm feeling like I might be learning something. Not necessarily the knowledge about what some of it might be, but I'll definitely know it.
Okay.
Answer-wise.
Well, that's good.
I'll use it for sure, though, to go find out what they're talking about. You know me. How does the intensity of an X3 flare compare to that of an X2 flare? Okay, so different classes here. So is it A, 10% greater?
B, 50% greater.
Or C, twice as great?
Or D, 4 times as great? How does the intensity of an X3 flare compare to that of an X2? Well, right off I would say it's one better, but that's not one of the answers.
That's not. You're right. This is one of those ones you probably had to know or study.
I don't think it's 4 times as great. 10%, that's not very much. I'm going to say it's either 50% greater or twice as great. I'm just going to stab at it. I believe it is 50% greater.
Yeah, I don't know this one, but there is several people in the chat room that are agreeing with you. Ooh.
Okay. I feel better now.
Got it. 50% greater. Wow. So from one to the next.
Yep. One step to the next. You really need to study this solar stuff. Because if you're like me, it's not something, an instinct you were born with, you know. What does the 304A solar parameter measure? Is it A, the ratio of X-ray flux to radio flux correlated to sunspot number?
B, UV emissions at 304 angstroms correlated to the solar flux index?
D, the solar wind velocity at 304 degrees from the solar equator correlated to solar activity?
D, the solar emission at 304 gigahertz correlated to the X-ray flare levels. Wow. Okay. If, again, like my B sub Z question, if I only knew what 304A solar parameter meant. Uh-oh. This one might be a pencil guess. See if I can't rule out anything that looks awfully strange. Why would they use 304A? Solar emissions at 304 gigahertz. I have a feeling this doesn't have to do with a band that not many of us. Well, I don't know. 300. I'm ruling out D. Solar wind velocity 304 degrees from the solar equator, correlated to the solar activity. What's the solar equator? You mean of the sun?
Yeah, I think that's what they mean.
UV emissions at 304 angstroms correlated to the solar flux index seems to be odd, but who knows? The ratio of X-ray flux to radio flux. What about solar flux or solar flux? Correlated to a sunspot number. I don't know. To me, it's B or C, and hold on. Oh, my pencil landed on C, George, and it's focused. Where'd it go? Okay, there it is. I don't know this one. Absolutely not. I don't know what 304A solar parameter measures.
Yeah. I'm not sure what this one is either. I can only tell you, I think the one that the pencil landed on is wrong. But I don't have a good reason for it. Well,
yeah, I'll let the pencil tell me the logic, and then I'll have to go learn it.
There are people actually answering the question, and they're all saying B.
Ooh.
The ones
all right,
who answered.
The chat room might get this one then. If I'm
thinking that may be it for some strange reason. Wow.
Oh, there you go. The chat room prevails.
You would think, though, it's probably not B because that one just sounds too obvious, 304A.
Yeah.
But it is.
I mean, that could have been the logic I went with, right?
Yeah.
Angstroms. That could have been. And in fact, now that you said it, I'll probably remember that if I get this on the test.
Okay. Well, you can thank me when you pass your exam.
That's right. I'm going to run out of there saying, I got that question, Professor. You were right.
Everyone
the chat room was right. Mm-hmm. What does VOACAP software model? Why did you get this one? Is it A, AC voltage and impedance?
B, VHF radio propagation?
C, HF propagation?
Or D, AC current and impedance? I would say this is one of the easier questions tonight. I see you shaking your head. Yeah, you agree with that. VOACAP. I always was thinking it was VOA cap, but VOACAP, that could be the name of it. Well, I just happen to know that that's software from the Voice of America that allows you to go in and model propagation. It's not AC voltage and impedance. It's not VHF radio propagation because VOA really wouldn't be interested in that. And it's not AC current and impedance. It's HF propagation. I just know this because I've seen the software. As a matter of fact, I was just looking at it the other day, trying to figure out a path between me and Nigel and what band, what time of day would be best. And you can get a pretty good model there to give you a good idea of when to try to make that contact.
So I know it from a different reasons, and I'll tell you after you show the answer here. There you go. C, you got it. HF propagation.
Everybody got that one. So how do you know it differently, Emil?
So being a part of when I first got the general license, automatically opened up the HF bands for me. And one of the things we used here in Hurricane Prone Alley here is the WinLink system software. And when you're on HF, it will calculate the path using and give you the best path to the not nearest, but the best path predictions using that VOACAP, Voice of America. What is it? See, and you got me wanting to. Voice of America coverage analysis program. And it's built into that, and it'll give you the best path to a station it thinks you're going to hit in WinLink.
Cool. Yeah, I didn't know that they had that in there. I've only vaguely looked at WinLink once. I need to do something with that, but I haven't.
It's amazing.
Yeah. Sounds like it is. Well, let's, Spike says he was right again just by accident.
Good job, Spike. What, the Voice of America was the HF station here in the States, right? That was broadcast into the military overseas?
No. They're all over the world, and they're broadcasting to other countries. As a matter of fact, I think their charter said they can't broadcast to Americans, but it was set up to broadcast to other countries.
Okay.
We did a tour of it, of one of the facilities that's been shut down now. I think maybe the one in Greenville, South Carolina is still on the air. I'm not positive.
All right. What you got for me, Professor?
How does the maximum range of ground wave propagation change when the signal frequency is increased? Another easy one. A, it stays the same.
B, it increases.
C, it decreases.
D, it peaks at roughly 14 megahertz. Okay. D's out the window.
Yep.
A's out the window. So, does it increase or decrease? Let's see. Maximum range of ground wave propagation change when this... Okay, so we were talking about this a little bit earlier. Oh, well, it's at least how much it would go past the horizon.
No, we were talking about VHF and UHF. Well, which could be included as part of this.
That's where my brain's going with this propagation change. Okay. So the waves are going to get smaller as the signal frequency goes up. I'm saying it's C. The range is gonna decrease for ground wave, that is, not skywave. It's ground wave. So frequency goes up, the maximum range is gonna go down. And that's my answer.
And that's everyone's answer in the chat room, and that's my answer as well.
Awesome.
And I can tell you the best example of this, and I wasn't thinking VHF and UHF when I was thinking about it. I was thinking HF and medium wave, because AM broadcast just in that band, that band's not real wide. It's very obvious in there if you know this. The different frequencies and the power levels of those stations. Everything that's on the left-hand side of the band down in the low numbers goes way further than anything on the upper end of the band, or the higher frequencies. As an example, one of the AM stations I took care of was WJDX here in Jackson on 620 kilohertz.
Still there, isn't it?
It's still there.
Yeah.
5 kilowatts during the day, and I picked it up 175 miles away one time. I mean, I had to stop and pull off the road and, listen, but I could tell it was there. But that station always had great coverage, and it was only 5 kilowatts. But it was on that end of the band.
Yep.
One of the AMs I have now under my belt is on 1180. It's 50 kilowatts, and it goes about the same distance that 5 kilowatts went down at 620.
Gotcha.
So those frequencies aren't that far apart, but it's real obvious if you know the powers and you listen to stations on there, that anything on the lower end, that's the better frequency as far as getting the longest ground wave with the least amount of power. Anything at the other end, if you're hearing some distant stations down there, I'm talking about during the day now, ground wave, they're going to be strong. There's going to be a lot of power there.
Well, that'll stick with me for sure. I appreciate that. What is it, like a meg and a half, that band, the whole band?
It's like from, what is it?
500? 20?
520 or 40.
Yeah.
I've never had a station that low in frequency. And it used to go up to 1590, 1600. But now it goes on up higher than that. It goes practically all the way up to just about 160.
Good, I'll remember that. What type of polarization is best for ground wave propagation? A, vertical.
B, horizontal.
C, circular.
Or D, elliptical. I know the answer to this one there again because of my profession. I know it very
and I think I have a visual for when you.
Okay. Yeah, everybody's saying about the same thing in the chat room. Emil, I know for certain what it is. What do you think?
I think it is vertical.
It
because,
is.
Yeah, that's what I think. And the visual I have is a wire in the air where the pattern goes up towards the ground and up towards the sky versus a vertical for which the pattern goes towards the horizon.
Yep.
So if you want ground wave towards the horizon, go vertical.
Okay.
That's my visual, at least.
That's a good visual.
Okay.
I can give you another visual, but yes, it is. It's a vertical, and everyone's saying that except Spike. And you said it was H.
Well, I was repeating after a Spike.
Oh, okay. This one's very easy to remember, too. If you think about the AM broadcast band, all of the antennas are vertical towers. Every one of them these days, or practically every one of them. When radio first went on the air, all of the antennas were what they call flat top, or basically as a dipole. They'd have two towers, and they'd string a wire between them. And, it'd be tapped in the center there. And all of the early AM stations were that way. I'm talking about really early. It didn't take them long to figure out that, hey, a vertical is going to have more ground wave. So everybody went to vertical.
Yeah.
So, yeah, easy enough on that one.
Those are some big wavelengths, that's for sure.
Why does the radio path horizon distance exceed the geometric horizon? A, E region skip.
B, D region skip.
C, due to the Doppler effect.
Or D, downward bending due to density variations in the atmosphere. Is this one me?
Yep.
All right. So, let's see. Why does the radio path horizon distance? Okay, so this is tied to that one we asked earlier. And I think I seem to remember saying to myself, when it gets past that boundary or the curvature, it goes 15%, I think is what we said. The answer was for a reason, for something. Why does it go there is what this question is about. And I'm going to say it's not E or D region skip. It's not A or B because that's talking about skywave.
Yep.
Okay. And C, due to the Doppler effect, seems weird. The waves are moving, but, well, the radio is moving relative to the Earth. So, yeah, no, not the Doppler effect. And it's got to be D. I'm thinking that reason is because of that atmospheric, the density of it, right? and how that constantly changes when it gets there, which is probably why it's 15% past and not much longer, unless ducting is happening or some other phenomenon.
Yep. I'm going to agree with you. Email. It's D. Little mixture in the answers there in the chat room. Let's see. And it is. And well, when I looked at the answers, I knew it wasn't A, B, or C, so it had to be D. Sort similar to what you did. But,
well, the professor has to look at the answers.
Yeah.
You're exempt.
Okay, we got one final question tonight.
What might be indicated by a sudden rise in radio background noise across a large portion of the HF spectrum? A temperature inversion has occurred.
B, a solar flare has occurred.
C, increased transequatorial propagation is likely.
D, long path propagation is likely. What might be indicated by a sudden rise in radio background noise across a large portion of the HF spectrum? Well, it's definitely not a temperature inversion because that doesn't really affect HF much. You know, that will affect higher frequencies than that, VHF, UHF, but it doesn't make additional background noise, I don't think. D, long path propagation is likely. No, the noise level went up across a big part of the HF spectrum. Propagation is not going to be better. C, increased transequatorial propagation is likely. No, there again, I think you're going to be fighting with the noise worse than usual. So if it's a sudden rise in a radio background across a big portion of HF, we know solar flares cause noise like that. And we've heard it before on HF, or you've likely heard it on AM radio as well, but particularly on HF. Yeah, it's B. A solar flare is going to be my answer. What do you think?
Yeah, I like your logic on that, and I think you hit the absolute part of that statement that needs to be looked at, which is the increase or rise in radio background noise. That's it. That rules out the last two right off the bat.
Yeah.
So, an A, is usually associated just from experience with tropospheric ducting, rather than HF. So, I like your logic.
Yeah, I don't think the noise level rises when you got a temperature inversion on any band that I'm aware of. So, a solar flare. Everybody got that one right in the chat room too.
Yep.
Okay. We have reached the end of the questions tonight.
On Tuesdays at 8 p.m., the Amateur Logic Soundcheck Net on Echolink, All-Star, D-Star, DMR, you name it. The KHJTK hub and Brad's Link and DMR and the fun machines for you name it. There's all kind of links here, and we have all sorts of fun, and it's great to get to talk to the people who are watching us and sending us stuff and, participating. It's great to hear them and talk to them. And we have a great group of rotating network operators and net operators. So that's where you're going to find it and be able to get in there.
And about half of them are in the chat room tonight.
Yeah. So. 73 in Abacus numbers to everybody. And be sure to check us out on the nets and on the next Amateur Logics, and who knows, there might even be an Amateur Logic short in between there.
There probably will be. As a matter of fact, I previewed one earlier today. Yeah.
I certainly hope it met the professor's standards.
I believe it did. I learned a few things too in the process there. So, yeah, something every week from the Amateur Logic and the Ham College crews there. So check them out. If you watch us on YouTube, please subscribe to the channel, click like on the videos, and let your friends know about it. That helps spread the word around and gives us ideas of what people like and sometimes of what they don't like as well. All right. Have a good week, everyone. If you are going to be taking your extra class exam or any class of license exam, probably you ought to do a little bit of studying. And we've got in the archives there the amateur radio technician and general class pools already covered out there. So go check those out as well on AmateurLogic.TV or on our YouTube channel.
Yep.
7-3.
7-3.